In the last lesson, we talked about some of the ways we could display quantitative data. We use dot plots and stem plots to display the data. Because quantitative variables often take many values, the distribution is clearer to see if the nearby values are grouped together. This is done by using what's called a histogram, which is the most common graph used. This is a dot plot showing the percent of foreign-born residents in each state. Yep, that's California. This is that same data as a histogram, grouping it in groups with a width of 2. I can change that width to 5 and look at it that way as well. You'll notice that it is going to be important how you scale your data. What are you going to use as your scale? When you get ready to make a histogram, it's important to follow some steps. The first thing you need to do is divide the range of data into classes of equal width. In those two histograms I just showed you, we had one of them a width of 2 and one of them a width of 5. So as you can see, the choice of width can influence the appearance of a histogram. The next step you want to do is to find the count or frequency, or the percent or relative frequency of individuals in each class. You want to label and scale your axis and draw the histogram. Okay, so this is a table of average points scored per game for 30 NBA teams in 2009 to 2010 regular season. Start that again. This is a table of average points scored per game for 30 NBA teams in 2009-2010 season. I made a frequency table and a relative frequency table here to take a look at what I want to do with the data. So I did graph it. This is the dot plot of that data. I can change that to a histogram. In this histogram, they're using a scale of 1. Let's change that to 5 and start at 90. Whoops. And see what that looks like. Whoa. Need to bring that down so I can see it. And bring that in. Yeah, there we go. Alright, so this is with a class setting of 5, starting at 90. So let's take a look at what it would look like if I change that to 2, starting at 90. Okay, big difference in the way it looks. So you have to decide how you want to display your data. Now let's take a look at the relative frequency table. Now this would be, I now have it as percent, so that's my relative frequency. It's in class of 2. My classes are grouped by 2s. Let's change that over to a 5 again and take a look at it, going by 5s. So going back to our histogram on foreign-born residents in each state, the first thing we want to do is look at the shape. If you notice that it's skewed to the right, remember that to the right means that the tail is to the right, the data is to the left. A majority of states have fewer than 10% foreign-born residents, but several states have much higher percents. Like I said, way over here is California. So the graph extends quite far to the right. The distribution has a single peak. The next thing we look for is outliers. Are there any outliers? We don't see any really evident outliers outside the overall single peak. From the graph, we see that the midpoint or median would fall somewhere in the 5% to 99.9%. So somewhere in this is going to be our median. Remember that we are looking for the value of having 25 states with smaller percents and 25 states with larger percents. And last of all, we're going to look at the spread. Okay? The histogram shows that the percent of foreign-born residents in the states varies from less than 5% to over 25%. Using this data and subtracting 27.2%, which was our highest, and 1.2%, we end up with 26%. So that's our spread. Okay, so why would we prefer a relative frequency histogram to a frequency histogram? Relative frequency histograms are typically more useful than frequency histograms. They make it easier to compare two distributions, especially when the number of individuals is very different. Okay, be careful. Make sure that you label your axes. This is a big AP exam error. Okay, so now would be a good time to check your understanding on page 39. So go to page 39, stop this, and go to 39 and check it. Okay, you can check your graph on a calculator. Describe what you see is the distribution bell shape. The distribution is roughly symmetric and bell-shaped. The mean IQ appears to be between 110 and 120. And the IQs vary from 80 to 150. There does not appear to be any outliers. Remember, outliers have to be way out there. What common mistakes with histograms will cause you to lose points on tests and projects and cause Ms. Hines and Ms. Truex to go crazy? Don't confuse histograms with bar graphs. Although they resemble each other, their details and uses are different. A histogram displays the distribution of quantitative data, while a bar graph is used to display the distribution of a categorical variable. The horizontal axis on a histogram is marked in the units of measurement of that variable. The horizontal axis on a bar graph identifies the categories or quantities being compared. When you draw bar graphs, there will be a space in between each bar. When you draw histograms, there is no space. When you draw histograms, there is no space in between the bars. The second thing, don't use counts in the frequency table or percents in the relative frequency table as your data. Your data is your data. Use percents instead of counts on your vertical axis when you are comparing distributions of different numbers of observations. For instance, if you were going to check the number of letters per word in two different journals, one medical journal and another an airline flight magazine. In the medical journal, you check the first 200 words, and in the airline magazine, you check the first 100 words. Your data would be misleading if you went by counts, But if you went by percents, you'd have a more accurate view of it. And then remember that just because a graph looks nice it's not necessarily meaningful display of data. But the big thing, don't confuse histograms with bar graphs. Make sure that you don't. Yes, there we go. Now would be a good time to stop and check for understanding. Okay, your answer to number 1 should look very similar to this. Your histogram for your second one should look a lot like this. Okay, number 3 asks you, is this a bar graph or a histogram? Well, obviously it's a bar graph because the horizontal axis divides the observations up into categories. Would it be correct to describe the distribution as right skewed? Why or why not? No. The variable is categorical, not quantitative. Remember that skewed left, skewed right, that is for quantitative data. Have a good night. Do your homework.